So here's another exam question about vectors from 2013, and it says OABCDE is a regular polygon. Write down the geometrical name for this polygon. Well, it's got 6 sides, so it's a regular hexagon. Now it's worth remembering about hexagons that you can construct a regular one from 6 equilateral triangles. That's going to be important later on because with these 6 equilateral triangles you've got lots of equal parallel distances. For example, through the middle is twice as much in the same direction as down the sides. So it says O is the origin, OB equals B, and OC equals C. So from O to B is a movement, which is referred to as vector B, and from O to C is a movement, which is referred to as vector C. And it says find in terms of B and C in their simplest form vector BC. So that's saying how do you get from B to C but only moving in directions of vector B and vector C. So one way you can do that is to start at B, go down to O, so that's a minus B because it's a B but backwards, and then once you're at O, go up to C, so that's a vector C. So one way of doing there is doing a minus B plus a C. So minus B plus C is a perfectly good answer, or you might write it as C minus B. The next question says vector OA, so that's how do you get from O to A, but only moving in terms of vectors B and C. So one way to get there is to go from O to B, so that's a vector B, and then go from B to A, which is in the same direction as vector C, but only half as far and backwards. So it's minus half a C. So one way of getting from O to A is B minus 0.5 C. So that's the answer. And in fact, any other route you choose to take should amount to B minus 0.5 C when you cancel out all of the B's and C's. So the next part says O is the origin, OB equals B and OC equals C. Find in terms of B and C in their simplest form the position vector of E. So it's worth reminding ourselves what a position vector is, and a position vector is a vector from the origin. So for example, if you have graph axes and the point 8, 3, then the position vector 8, 3 takes you from the origin to the point 8, 3. So it's the vector with the same coordinates as the position it takes you to from the origin. So we've got to find the position vector of E. In other words, we've got to find the vector OE from the origin, point O, to point E. And we've got to do that in terms of only B's and C's. So one way to get there is starting at O, go up one C vector to point C, and then from there go backwards along a B vector to get to point E. So from O to E we can achieve that by doing a C and then a minus B, a backwards B. So the answer is C minus B. The position vector of E is C minus B.